So before we look at the echo machine, we'll look at the basic property of sound wave, because when we say echo, we're using ultrasound to look at the heart, and you have ultrasound of the abdominal organs, and similarly they use ultrasound to look at the organs. But this is echocardiography, where we use ultrasound to look at the heart. So we're going to look at the basic properties of the sound wave. Then we look at the echo machine and the care for the echo machine. So again, when we say echocardiography, is a use of ultrasound to view the heart. Now, we look at not only the structure, we look at what the heart looks like, but the function of the heart. We look at the circulation of blood in the heart. We look at the valves to make sure the valves are working properly. We have what we call transducers or probes. These transducers or probes, they manufacture the ultrasound wave, and the ultrasound wave travels to the tissue, bounces off the tissue, and come back to the ultrasound probe and convert those ultrasound waves into images. So that's basically what ultrasound is. You create the ultrasound wave, which travels to the organ. It reflects off the organs, come back to the ultrasound, to the transducer, and those sound waves that comes back are transformed into images. So you see a picture. Now, the transducers that we use emits ultrasound with a frequency of 2 to 17 megahertz. So this is something that you have to know, and we'll go over this from time to time. Clinical ultrasound, when we do ultrasound anywhere in the body, we use a transducer that's going to emit a frequency of between 2 and 17 megahertz. When we look at the human hearing, we have a range which we hear between 20 hertz and 20,000 hertz. So that's the range of human hearing. Those are frequencies that we can hear, 20 hertz to 20,000 hertz. So anything above the 20,000 hertz is called ultrasound, because this is the regular sound frequency that humans can hear. So when we say ultrasound, it's a frequency which is greater than this 20 kilohertz. Okay, so kilo means 1,000, so it's 20,000 hertz. So when we say frequency, what are we talking about when we say frequency? So if you guys did physics or have any concept of frequency is how frequent some things occur. So the name says it all. It is a number of complete cycles per second. So that's a specific definition. We know that frequency is how frequent something occurs, how often something occurs. So the physics definition is the number of complete cycles per second, and that's called the hertz. So if we were to show this in a cartoon, then one cycle would be, if you start here, then you move down here, you move up, and so this would be one cycle, okay? And this scenario have 2 cycles, this one have 3 cycles, and this have multiple cycles. So this would be a low frequency situation. This would be a medium frequency, and this is a high frequency. Again, the definition for frequency is the number of complete cycles per second. So you have 1 second and you just count the number of cycles, and that's straightforward. Now, there's another thing in ultrasound that you need to know, is what we call the wavelength. So essentially, that's the length of the wave. This length of one cycle. So it is the distance between one peak or crest and the next corresponding peak or crest. So the distance between the cycles. which is, again, straightforward. That's a wavelength. So what is the relationship between frequency and wavelength? Well, the speed of sound, well, it varies in the different medium. The speed of sound in air is a certain number. The speed of sound in water is another number. The speed of sound in a solid is another number. So the speed of sound varies, and it varies depending on the frequency and the wavelength. Okay, so this is what we call the wave formula, where the speed is equal to frequency over the frequency times the wavelength. It is sort of straightforward. Just think about it. What is the definition for speed? Speed is distance traveled per unit time. That's the standard definition. But remember what we said, the distance traveled for the wave is the wavelength. Okay, the distance traveled is the wavelength. And if we divide the wavelength by the time it takes, so the time it takes, so let's derive the formula, because you should, if you know how to derive the formula, then you don't have to memorize it. So again, if we say that speed is distance over time, and again, this is in all situations, distance over time. And we say that the distance, the wavelength is the distance traveled, or the length between the one complete cycle. So that would be the wavelength. That's the distance. And then the wavelength divided by time. So that is the speed. But what is frequency? Think about it. Frequency is the number of complete cycles per second. So if you were to look at it, the time is going to be 1 over frequency by just by the definition alone. So we say that frequency is the number of complete cycles per second. So it is a number over time. So frequency is the number of complete cycles per second. So one frequency is equal to 1 over time. So what you realize is that frequency is inversely related to time. So when we say something is inversely related, that means it's 1 over that quantity. So this is wavelength times 1 over time. 1 over time is equal to frequency. And that's how we get speed equal to frequency times wavelength. So you have to memorize this because this is important. Okay? And the speed of the ultrasound in a medium is very important, because if someone is talking to you, the sound wave that is created is going to take a little time to get to your ears because it has a speed. The speed of sound in here is about 331 meters per second. These are numbers you need to memorize. The speed of sound in soft tissue is 1540 meters per second, much faster. So those are the things you have to remember. All right, it's important, and because it's gonna live with you throughout your echo training. Okay, so another pictorial showing you that. Okay, so the wavelength is the distance between, say, one crest and the next crest, or one trough and the other trough. Okay, that is the wavelength. And when we talk about the amplitude, it is from the baseline to the maximum displacement, and it can be either up or down. Okay, and then the frequency is the number of cycles per second. Remember that. You have to remember those little things. And as we said before, 1,000 hertz is a kilohertz, and 1,000 kilohertz is a megahertz. Again, clinical ultrasound uses transducer with frequency between 2 and, say, 18 megahertz. So when you look around, you go to the office, if you're curious, you can just find out what is the megahertz of this transducer. Anything we do in clinical practice, the frequency of those transducers or probes are going to be between 2 and 18 megahertz. Another important thing to remember is that period times the wavelength is equal to 1. Okay, so if you think about it again, the time to complete one cycle is what we call the period. The distance traveled for one cycle is the wavelength. So the product of those two is 1. Okay. So again, looking at wavelength is the length of one cycle. The period is the time it takes to complete one cycle. So that that product of period times wavelength is 1. Again, another pictorial showing you the amplitude. You can see this is the wavelength, or the period, the time it takes to travel one cycle. And then the amplitude is the maximum displacement from the baseline, and that's the amplitude. And you will see the importance of these physics when you start doing ultrasound, because when we talk about power, it is the measure of the sound energy per unit time. So power is just the energy per unit time, how long you supply that energy. And then the watt, the unit of power is watts. So energy per unit time is the same thing as watt. And the power is proportional to the square of the amplitude. And that is why amplitude is important, because if you want to increase the power, all you do is increase the amplitude. So these lectures are on YouTube. They are on the YouTube channel, so you just go on and you can look at them a million times. We will send you also we'll email you copy of these slides, but these lectures are posted on our YouTube channel, so you can just go over them. Okay. So again, if you want to increase the power of your ultrasound, you just increase the amplitude. So, and then there's something we call intensity. So the intensity is the power per unit area and cross-sectional area we're talking about. So if you want to increase the intensity, you can decrease the cross-sectional area or increase the power. And power, the unit of power is watts, and cross-sectional area is in meters squared. So that's it. As we talk about the velocity of sound in the different media, you can see that it's not a constant number. So just think about it. When you talk or when you shout, in the sound is going to travel in the air, and the speed is about 331 meters per second. And so when we do ultrasound of the body, say we do ultrasound of the abdomen or even the heart, the sound wave is going to travel through soft tissue, and that speed is 1540 meters per second. Okay? In water, it's similar to soft tissue. In blood, it's a little bit more, 1570 meters per second. And you can see in bone, the bone, it's 4080 meters per second. All right, so you'll get those things. Don't stress too much about it. So the echo machine, the echo machines are all the same. So they look complicated, but once you learn one echo machine, you know it all. So the echo machine, they have a monitor. You have to see what you're doing. And then there's a console with a number of buttons, and we'll let you know what the buttons mean. See this is where the transducer plugged in, or the probe is plugged in. So the probe or the transducer is plugged into the machine, okay, these areas. And then you can position your transducer, say, at the side. And we usually put it at the side, and each machine will have a number of different transducer or probe. So when we say transducer, it's the same thing as probe, okay? And that is what you put on the patient's chest. The transducer probe is going to create the sound wave. It's going to travel through the chest to the heart. It's going to reflect backwards to the transducer, and you're going to see the image on the monitor. So these are some of the buttons that you want to have. And this is a trackball. You can move stuff around with the trackball. This is a 2D button. So if you want to see your grayscale, and we'll go over that, don't worry, but if you want to see your two-dimensional image, you press that button. If you want to see an M mode echo, you press this button. And then we have Dopplers. You have a pulse wave Doppler button. You have it's a PW, continuous wave Doppler button, color flow Doppler button. So you press that button. And then there's a zoom knob. This zoom knob, you can increase the size of the image, because sometimes you want to increase the size of the image, especially if you're going to do measurements. And then the depth, if you decrease the depth, you're going to increase the size of the image. So you can change the size of the image depending on the depth. And then these are gains. When we say gain, it basically makes the image look brighter or duller. You have to turn the machine on. So there should be a power button. And once you get to a machine, look for the power button, because you need to know how to turn it on and off. Okay. And not only to turn it on and off, you have to record what you're doing. So there is a button to record. So you record what you're doing. So those are the basics. You can freeze. So it's important to you have a freeze button. You freeze the image because you want to do measurements. So if you're going to do measurements, you freeze the image, and you can either do caliper. So with caliper, you do some quick measurements. If you want to do comprehensive measurement, then there's a measurement package that you go into and do your measurements. And again, you can record what you're doing. So, and then this is a keyboard. So all this is a keyboard. You put in the patient demographics, the name, the age, date of birth, sex, blood pressure, stuff. So a regular keyboard. When we talk about gain, there's a button for overall gain. So to increase the brightness or decrease the brightness. So this is a 2D gain, and then there you can change the brightness of specific area in the heart. Okay, so again, so this is a description of the buttons. So know the different buttons, and when you come across any machine, just see where you locate the button. So again, you have a freeze button. That button fix the image, freeze the image. So you can do measurements and you can move it back and forth so you can properly evaluate structures. That's a freeze button. And again, the two-dimensional button, you're going to obtain your B mode image. That is the grayscale image. The image that you usually see of, say, the echo, that is what we call B mode. So you press the button and it shows you that. Again, there's a PW button. So Doppler, we're going to go into Doppler. Right now, you have no clue what Doppler is. Don't worry about it. But there's a button. When we press that, you get a pulse wave Doppler. And then there's another button, CW. When you press that, this displays continuous wave Doppler. So CW stands for continuous wave. And you will understand what that means later on. Don't sweat that right now. And then there's a color flow button, and it's going to display color flow Doppler. Then there's a cursor button. So if you wanna say do a M mode of a specific area, or you wanna evaluate a specific area, then you put a cursor button. It's a line of interest to Doppler or M mode, a point of interest. So if there's a specific area you want to highlight, then you use your cursor button to do that. M mode is another type of echo, motion mode, and that's going to display motion mode images. So you can do your two-dimensional image of any structure, or you can do M mode. Again, don't worry too much. You'll understand what these mean later on. And then the caliper is for simple measurements. Your simple online measurements, you want to measure the thickness of, say, the septum or the LV cavity, you can quickly do that. If you're going to use the measurement button, it's going to give you more detailed online or offline measurements. Then the zoom button is going to enlarge a point of interest. So if you want to enlarge something to do some measurements, you can do the zoom button. Then there's a depth button to change the depth to make the image larger or smaller. And all machines have a record button. So you're going to store the image for later retrieval. Power button to turn the machine on and off. Gain button just to change the brightness of the image, because sometimes the image is very dull and you want to brighten it. So you can use the overall gain button to change the brightness. If you want to just change the brightness of a specific area, there's something you call the TGC, time gain compression button, okay? And you manipulate that and you can change the brightness at different areas, different depth. Trackball, we use a trackball for moving objects on the monitor for measuring, the cursor for the Doppler. Once you start using these things, then it's second nature. You don't have to memorize this. And then the keyboard, demographic indication for the study, all that sort of stuff. So as we have been saying, the probes is the stuff that you put on the patient's chest. That portion of the machine that you put on the patient's chest, and you rub it in the patient's chest to get the image. So the probe are the same thing as the transducer. It makes the ultrasound wave and it receives the wave. So it's going to make the wave, send the wave into the chest. It strikes the different structures in the heart and it come back to the probe, and you see images. The probe have some crystals, we call them piezoelectric crystals. When you plug the machine in and you plug the probe in, these these piezoelectric crystals, they vibrate to create the sound wave, and that's what we call the piezoelectric effect. So they create the sound wave and they send the sound wave into the patient's chest, okay? And then they're reflected back to the probe and you see images. So it's a straightforward thing. There are different types of probes. You have the linear array, sector array, curve array. Again, don't get bogged down in all of this. You will, things that is important, we will stress it. So things that are important, we'll stress that later on. So you don't have to memorize all of this, okay? But these are the different type of probes that we have. Again, clinical ultrasound use probes with frequency between 2 and 18 megahertz. When we're doing adult echo, so when we're doing adult echo, we use probes usually between 2.5 and 4 megahertz. So you have to know this. So if you're going to do an echo of a patient, you have to get a probe between 2.5 and 4 megahertz. If we're going to do transesophageal echo, where we're going to put the probe in the patient's esophagus to look at the heart, then you need a probe with a frequency between 3.5 and 7 megahertz. When you do vascular ultrasound, so you want to look at blood vessels, you have to use probes with a somewhat higher frequency, 5 to 10 megahertz. So that's important. So you'll have to know the difference. So, and again, just have the basic understanding of the probe. The probe is the stuff that we'll put on the patient's chest. It's going to create the sound wave. The sound wave is going to travel to the patient's heart. It's going to reflect it backwards, and then once it goes into the probe, it's going to create images. So these piezoelectric crystals are in the close to the front of the probe. Okay, and then you have some electrodes. You have something we call the backing material, and then the cable. Okay, so these piezoelectric crystals vibrate to give you the ultrasound wave, and this is what different probes look like. So you'll see probes looking like this, like this, like that. So these probes have these crystals. When you plug the machine in, they create the sound wave. So the sound wave is created in the probes. And remember, the different probes have different frequencies uh, depending on what structure you're going to look at. When you do transesophageal echo, this transesophageal echo, it has what we call an endoscope. So it has this narrow tube that we can pass in the esophagus into the stomach, and there's a camera. There's a small camera on the tip, okay, which allows us to image the heart, and then this is connected to the ultrasound machine, okay. But this portion of the probe, the transesophageal probe, is going to go in the esophagus. So you have to clean this, properly after each use. So we come now to the transducer care and cleaning. You're going to put the probe, if you're doing a transthoracic echo, so you put the probe on the patient's chest, the probe is exposed to the body fluids and stuff like that. So it's important to clean the probe after each use. After you finish one patient, you should clean the probe. Okay, so the transducers must be cleaned after each use. So before you use the probe, you should look for cracks or any damage. Okay, and some important thing. So you have to you have to clean the probe. You have to disinfect the probe, and you have to sterilize the probe. You have to be very gentle because these probes can be damaged. So you have to be careful. With the transesophageal probe, you have to be careful. You don't want to bend it too much, okay? Because you can damage the probe. Do not brush when you're cleaning it. Do not brush it. Um, you know, You shouldn't use abrasive paper. So you sort of have to, damp the transesophageal probe. And with the transesophageal probe, there, you have the gastroscope that goes into the esophagus, or that endoscope. The connectors, keep the connectors out of the cleaning solution. You don't want to get that wet. So you don't want fluid to enter into the connectors. Okay, well, we'll show you what that looks like. There are specific cleaning agents that is recommended. Use a soft cloth, and you're going to do a blotting motion for drying. Do use rubbing alcohol on the transducer cables, because that's a fire hazard. So do not use rubbing alcohol, which is 70% isopropyl alcohol. And again, use disinfectants that are recommended. When we're doing transesophageal echo, we use something called a bite block, because we don't want the patient to bite down on the probe and damage the probe. So some of these transesophageal probe are 40 to 60,000 US dollars, and you don't want the patient to bite down and damage the probe. If you're going to do, sometimes we have a sterile covering for the transesophageal probe, or even for the transthoracic probe, you can use sterile covers, but that's not important. So this is what a regular probe looks like. So you have the connector, then you have the cable, and then this is the probe itself. There's a lens right there, okay? So this is what a regular transducer looks like, okay? So this is the portion you put on the patient's chest. The piezoelectric crystals are here. Once you plug it in, it's going to create the sound wave. The sound wave is going to travel to the patient's chest. It's going to come back. It's going to strike the probe and create the image. And then these are the cables, and this is the connector that you connect to the ultrasound machine. Again, you have to clean the regular transducer after each patient use, because we put gel when we're doing transthoracic echo. When we say transthoracic, that means we put it on the thorax. It's not transesophageal. So we'll talk about transesophageal, where we put the probe in the esophagus. That's transesophageal, and then transthoracic, we basically put it on the patient's chest. You want to clean off the gel, because we put gel on all ultrasound technique, we use gel. You want to remove the gel, and then you're going to use recommended cleaning solution to clean the probe. You don't want to use 70% alcohol, rubbing alcohol, and you can do low-level disinfection, high-level disinfection. Just clean the probe, okay? So when you're cleaning the probe, you disconnect it from the machine. Use a soft cloth. Okay, you don't want to use something that's abrasive, okay? And you want to wipe or spray the cable. You want to hair dry it. And again, you need to look for damage after each patient use. Look for cracks, damage, or splitting. So your transesophageal probe or transducer is a little bit different. So you have this gastroscope, which is this flexible probe that you're going to put in the esophagus. And at the tip of it, you have a camera. So you have a lens right there. And this distal portion, you can move it. This distal portion, we talk about flexion, you can bend it upward. So that's anti-flexion. And you can bend it backward, we call it retroflexion. And you can move it from side to side, okay? So this is flexible gastroscope. This is some controls, because these controls control how you're going to move the tip, and you can also move the camera. Okay, the camera can go from 0 to 180 degrees, and so all the connections are right here. Okay, so these connections allow the distal tip to bend upward, bend backward, move from side to side. And then this is the cable, and disconnect the transesophageal probe to the machine. Okay. Again, you have to clean the transesophageal probe after each use. You have to use gloves because the cleaning solution can be somewhat toxic. So you have to use gloves, high wear. Again, do not bend the shaft too much because you can damage the probe. And you have to immerse it in these cleaning solution. Okay. And there are side effects. So you can, when you go to the different offices, you can look and see what cleaning solution. There are usually some Sidex products. You have to make sure that you clean the transesophageal transducer properly. You have to make sure it's cleaned properly, because if not, they can get temporary staining of the mouth and the lip area, and the cleaning solution sometimes can cause burning of the mouth, throat, and esophagus. So when you clean the transducer, make sure it's properly rinsed off. Allow it to air dry, okay? So you can hang it on a wall mount and allow it to dry. And only use disinfection solution that is recommended. Do not use anything that is not recommended. So this is what you do with the transesophageal probe. You have a basin with the cleaning solution, and you just put the gastroscope in the solution. The connector, the controls and the connector should be outside. It should be elevated, and you shouldn't get it wet. Don't get it wet. All right. So that is the introduction, and I think it's a good place to stop.